In less than 10 minutes, you'll be able to scrape product data from Target easily and at scale. Tracking data across a massive retail store like Target by hand is, realistically, not feasible. With hundreds of categories and countless brands, manual collection just isn't a reliable option. But that's exactly where web scraping comes in. I'm Arnas from Oxylabs, and I'll show you how to build an automated web scraper for Target product data using Python and Selenium. Before we get into the technical side, let's take a quick look at what Target's website actually has to offer. To keep things focused, let's run a search for something specific, like laptops, for example. As you can see, Target lists each product with its price, title, rating, and some extra stats like review counts and purchase numbers. Any of these fields can be scraped, and which ones are useful really depends on your own use case and what you're trying to track. For our script, we'll be grabbing the title, price, and rating for each product on a Target search page. Now let's get our environment set up. Open a window in VS Code and launch a new terminal. Run this command to create a virtual environment for your project, and once that's done, run this next command to install the libraries we'll need. We'll be using Selenium for browser automation and Beautiful Soup to extract the data from the page. Before writing any code, it's worth understanding the structure of the page we're scraping so we know exactly what to look for. Let's open up Target and search for cat food. Once the page loads, right-click anywhere and click Inspect to open up DevTools. In most browsers, there's a pointer icon that lets you highlight specific elements on the page directly. If we click on a product title, it lights up right away in the DevTools panel. From here, we're looking for attributes that'll help us identify each element later in our script. As you can see, the product card, title, and price each have specific data test attributes, so make a note of those as we'll be using them shortly. The rating element uses a CSS class instead, and we'll use that to pull the rating. Now that our environment is ready and we know what we're targeting, let's start writing the script. Create a file called main.py and begin by importing the libraries we installed. We'll need a handful of components from Selenium along with Beautiful Soup. With that in place, let's define the selectors we found on Target's page as separate variables like this. Next, let's initialize our Selenium WebDriver. Modern Selenium comes with Chrome built in, so there's nothing extra to install and we can just define it directly. We'll also set a couple of options for it, specifically enabling headless mode, which lets Chrome run as a background process and keeps things cleaner overall. With the driver ready, we can point it to the Target search page for cat food from earlier. One important habit to get into with Selenium is quitting the driver once you're finished with it, like this. It ensures no processes are left hanging after your scraper finishes running. A key part of using Selenium is making sure your data is actually loaded before you try to access it. We can handle this with an explicit wait, where we tell the driver what condition to look for before moving on. In this case, we can use one of the selectors we defined before and tell the driver to wait for at least one title element to appear on the page. We'll also set a custom timeout of 10 seconds, just in case nothing loads at all. Assuming everything loads correctly, we can extract the HTML of the page from the page source attribute like this. From there, we pass that HTML into Beautiful Soup, which gives us a clean way to pull out exactly what we need. We'll create a soup object and use our product card selector to locate each item on the page, collecting them all into a list. Then we'll define an empty products list, loop through each card, and extract the data from each element we've found. It's good practice to verify that each element was actually found, in case the page structure ever changes down the line. With that in place, we create a dictionary for each product and add it to our products list. If all goes well, this list should contain the fully scraped data from the target search page we looked at. However, it's important to be able to access this data after the script has run. The best way to do that is to store the list of products in a separate file using a well-known format. We'll use JSON for this example. We can import the JSON library, create a JSON file, and write our results into it. Our scraper is ready, so now let's put it to the test. Let's swap out the cat food search for laptops and run the script with python main.py. After a moment, you should see a success message in the terminal along with the products.json file appearing in your project folder. Open it up and you'll find a clean, structured list of laptops currently available on Target. We've built a fully functional, automated web scraper with Selenium and Python. It works well for a single run, but what happens when we scale it up? In a real-world scenario, you might need to run this more frequently or across a much larger dataset. And on a site like Target, that's more likely to trigger anti-bot measures. These can include IP rate limiting, CAPTCHAs, or even silently serving degraded content that's difficult to detect. There are a few ways to work around this. Adding random delays between your requests is a good first step, as it makes the scraper look more like natural human browsing rather than an automated process. But if you're still getting blocked, the most reliable solution is to use proxies with rotating IP addresses. This makes it much harder for the site to identify your scraper, as requests appear to come from different locations each time. You might also want to check out Oxylab's Web Scraper API. It's a highly scalable solution for web scraping of any kind. One last thing before we wrap up. Always scrape responsibly, which means respecting the site's robots.txt file, caching where you can, and adding delays between your requests to avoid overloading the server. We walked through how to scrape publicly available product data from Target using Python and Selenium. If you have any questions about web scraping, email us at support@oxylabs.io or use the live chat on our homepage. Thank you for watching and see you next time.